Hello everyone. Thank you for joining our next Bitdev, and this one is on Coinswap. And today we are gonna go into the in-depth discussion and the description of what Coinswap is and what is this protocol and why it's kind of important, and so far like how close we are to have this protocol developed. So let's get started. Usual drill is, if you have any questions, feel free to stop me in between or ask away in the chat. Both thing works, and do ask away questions. There is no stupid questions, and we can take as much as time as we need in each of this section. We will cover history of the protocol and how was it developed, a bit of like the academic chronology of how it was done. Then we'll go into the theory of the protocol, and there we will try to see like what it is, how it works. It kind of same as lightning, and we'll see how the mechanism works. Then we'll look at the current project where we are developing Coinswap, and what's the status, and we'll also try to do a demo. On the next episode, we will do a thorough code walkthrough. I'll try to give a brief intro of the code structure, what we have, and then like we'll run a whole demo where you see the theory part played out, right? And then we'll have some contributing guideline for people who want to contribute into the project and go ahead from there. So, okay, so we'll get started with this. Any questions or initial thoughts so far? I'll take a short pause and then I'll dive in. Okay, cool. So let's talk about the history. So Coinswap, like let's talk about the definition of Coinswap. So Coinswap is an on-chain atomic swap protocol. So that's like one line description of what it means. And it means it's an on-chain protocol. That means like you need to make on-chain transactions while doing this stuff. And it's an atomic swap protocol. And atomic swap protocols are not a new thing. They have been thought of, kind of implemented, designed in from the very early days of Bitcoin. And this is like, the idea is atomic means like it's a process that either happens or does not happens. There is no in between state where you can get stuck. So that's why it's atomic. And it's a swap protocol. Swap protocol means is like something changes from in the on chain, something changes from one place to another. Like UTXO gets spent from one UTXO to multiple UTXOs or stuffs like that, and on-chain action. And there are various kind of actions. One of those actions are swaps, and there are various kind of swaps. You have like multi-chain swaps where you can do swaps between Bitcoin and Liquid, Bitcoin and Lightning. In early days, people were doing like Bitcoin Monero swap, Bitcoin Lightning swaps, and different other kind of swaps. We will talk about a specific kind of swap, which is like UTXO ownership transfer swap. And this kind of swaps are interesting because what happens is like the UTXO ownership of different UTXO, the ownership of different UTXOs, that means like who controls the spendability of that particular UTXOs gets swapped between two participants. And there are some effects and some privacy benefits of doing that. So the protocol was quite old, and it was first talked about and first ideated by Greg Maxwell 2013, and it was one of the first protocol ever chalked with HTLCs even before Lightning. And people find out how to do swap with HTLCs before people found out how to do payment channels. Payment channels are much more complicated, and swaps are rather simple. And in HTLC swaps, the idea is very simple. We'll dive deeper into the theories of it. So if we read through the motivation, so here's the link for the chat, link for it. Hold there, and this is that chat forum, and he detailed out like how the whole thing will look like, what are the communication steps, comparison to CoinJoin. CoinJoin was already a known privacy protocol back then, and there are some like advantages and disadvantages for doing this rather than CoinJoin. For one, the disadvantage is like this takes more fees, and this is like a costly privacy gain on chain. And if Bitcoin transactions fees are very high, a lot of swap like this might not make a lot of sense. So that's the trade-off. But the nice thing about this is like it has a property called passive privacy, and passive privacy means like you get privacy even if you are not coin swapping, and because someone else is coin swapping, and that's something does not happen usually. And coinswap has this nice property, or this kind of like atomic swaps of HTLCs has this nice properties that you can design it such a way that that you have like passive privacy. And that's why like this is an interesting protocol, and this is for people who are interested in Bitcoin privacy, or interested in other privacy coins or zero knowledge proofs and stuff like that. These kind of protocols become important to maintain Bitcoin's fungibility. Along with CoinJoin, PayJoin, and other stuffs of protocol that we can use, there are like various problems of like having these protocols. One is like the censorship resistance part. We'll talk about all these things in the detail. I don't want to like make it elongated, but this is like the motivation. And okay, so some question. So let's take it.
Yeah, so my question was around fact that you mentioned that Coinswap is more expensive, and I'm not sure like why is that so. So CoinJoin, in case of CoinJoin, I understand that a lot of people pull in, and so you have one transaction getting out and breaking into 50 other, like 50 or so folks will pull in, and that's going to be a one big transaction. So miners might charge a higher fees on that,
All
whereas with
right.
Coinswap be off chain, the price should have been lower for Coinswap, right?
No, not really, because it's not an off-chain protocol, it's an on-chain protocol. So there is no off-chain atomic swaps. And so because it's on-chain, that means like you have to create more than one transactions. And in fact, the client end up paying fees for all the maker transactions and taker transactions. So it's not just one transaction, it's a few bunch of transactions that you have to pay fees for, and that's why it's an expensive protocol. And we'll see in details why that's the case. I guess that answers the question. Okay. So okay, we'll just read through the motivation part of it. I don't know if you guys can see it. I'll try to zoom in. So what the motivation was, like Alice would like to pay Bob, but doesn't want the whole world or even Bob tracing her transactions. Carol offers to receive Alice's coin and pay Bob with an unconnected coin. But none of these parties trust each other, and Carol being able to steal coins makes Carol into a systemic risk. Since the need for the trust means that there can't be many Carols, and Carol would be earning income on the side spying on Alice, or could get robbed, etc. And then it goes on, and then it like detail out the motivation. But the initial motivation is like Alice would like to pay Bob, but doesn't want the whole world to know. And he wants to do it via Carol, who is kind of like a service provider. And Carol would like to earn some fees. At the same time, Alice, Bob, and Carol, nobody trusts each other. They don't know each other. And Carol has like all the possibilities and potential to cheat. Now, the question was, how do we do it? And why do we want to do it? Because Alice would like to pay a Bob that he doesn't want the whole world to know. Because if you can do this, then you have a situation. There's Alice makes a payment to Bob, or Alice makes a payment to himself, or Alice makes a payment to somebody else, and that somebody else doesn't even know who Alice is or where the payment came from. And you break the transaction graph at that point where if you trace through the transaction in the blockchain, the ownership of the coin actually went somewhere else, and you cannot see that happening in the blockchain. and that is like one of the most important heuristics with which transaction tracing works. And so this kind of like makes a big blow on the transaction tracing idea, if we can do it. So that was the question. And then Maxwell went on and created a draft idea of like, he also mentioned some history about like how this motivation came, and then he details a swap protocol, and this swap protocol is what we now know as like the Coinswap protocol. And this was like the same, like the screenshot of the swap protocol, and you can see like certain kind of communication happens. It's like any other kind of protocol, for example the Bitcoin protocol or the Lightning protocol, where different parties are like talking with each other, sending some data around and trying to do something that they both want. In case of Lightning, they want to flow HTLCs through through the nodes and create a payment channel like that, bidirectional. That's what Lightning is. And this one uses the same basic. Like if you look at, like we'll like just the next slide, we'll look at the basics of it. The basics of this and Lightning is exactly the same. Like um, for first like 50% of the protocol, you do the same thing you do for lightning channels. And then it diverges from there in terms of like what happens next. And that's the protocol. So is that a clear enough description? And that's all in there in history. It's a fun post to read through. And I hope that's like it's clear so far. I like it's probably not clear at all at this point, but um any questions, any thoughts, some breakpoint now.
I think Chris defined it eloquently when he mentioned, like, without taking Lightning's example, what he said is, as long as the payments are atomic, there's a way for both the parties to ensure that they will receive the fund if the other
Mhm.
party will receive fund which was promised.
Yes,
And
yes.
so that can be used, that property can be used to build up secrecy.
Right. Yeah. Yeah. That was the whole idea. And uh yeah, and we'll see in details how it will work. Yes, Faisal, go ahead. Faisal, can you hear us?
Yeah, sorry, I was in mute. You can hear me now?
Yes, we can hear you.
All right. So you might cover this during the course of the discussion, but the question was relevant to what you've covered thus far, so I thought of asking it. Is it a prerequisite that Carol needs to transfer her coins to a two of two multi-sig account with Bob first before Alice does that?
From you were saying from this diagram as it sees over here, like Alice to Carol
Yeah,
to
I mean,
Bob.
there are going to be two escrow accounts, right? One is going to be between Alice and Carol, and the other is going to be between Carol and Bob, right?
Yeah, right. So yeah, so the way it works
So is
is
it a
this will happen first and this will happen second. So it goes from first peer to second peer to third peer to fourth peers, things like that. So that's how, like, yeah, that's a good question, because it's kind of like initiating payment channels between different parties, and the question is like, who initiates first, which channel opens first, and the answer is this channel opened first, then this channel, then this channel. And if it's like a kind of like one possible swap is like a circular swap, you can imagine a lightning payment going from Alice all the way through the node and coming back to Alice. And you can imagine a swap also in that way: Alice to Carol, Carol to Bob, Bob to Alice again. So Alice sends some coin, Alice gets some coin. And same thing for Carol: Carol sends some coin, Carol gets some coin, Bob sends some coin, Bob gets some coin. Everybody sends some coin and everybody gets some coin. And that's how the protocol flows goes. And the settlement is
okay?
exactly opposite of it. It's kind of like the same idea as Lightning. When the settlement happens, this one goes out first, this one goes out first. By goes out first, I mean like which time lock expires first. So this one expires first, this one expires first. Oh, sorry. I guess like this one, oh yeah, this one expires the last. So This first, this first, this first. So you go this way, you trace back this way.
All right, thanks.
Cool. Yep. Any more question? We'll have some more historical anecdotes, but we'll not go through the details of it. Just I'll just list them out. Then what happened is like it was like a protocol kind of like sitting around for another 4 or 5 years, and then people were like developing coin joins, p joins, and other kind of protocols, and people were working on side chains. Then Lightning happened, but this idea basically was like hidden inside this like long list of Bitcoin talk forum as a post. And nothing happened after that until Chris Belcher, he developed Join Market, and he was a long-term privacy researcher in Bitcoin. And he took up this idea and created a detailed post on Bitcoin mailing list. This post was in 2020, and so like almost 7 years, and 7 years later Chris Belcher comes and he like does the whole math and details out the protocol for the first time, how the miner fees will work, who will earn what fees, how the time lock will expire, how the multi-sig will look like, and all these kind of like other edge case situations that needs to handle. Like the problem of this protocol is like it's a quite complex protocol. Like lightning also is very complex, and there are like edge cases that the protocol needs to handle. And so he details out all the edge cases and all the deviation cases where like there are like two kind of edge cases where like somebody does something nasty, somebody like breaks the protocol, breaks the rule, and does something that he was not supposed to do. Then what happens? And then there are like deviation cases where it's not a malice, um, it's like somebody failed to do some action, and those are like the deviation stuffs. We will like have a second session where we will talk about the code and these abort cases and deviation cases in more details. Many of these are like almost all of these are already implemented, so the protocol is handling them. And so yeah, this was the first detailed post on this whole idea, and it's quite long to read. But then like Belcher went really serious about it, and he wrote like another gist in GitHub, which is known as the design for the Coinswap implementation for massively improving Bitcoin privacy and fungibility. And he detailed out the design even further, and he identified even more situations and more enhancement on the protocol that can be done than that was like originally listed in the mailing list. And one of those idea was using ECDSA 2p. The original idea was using vanilla multisig, but ECDSA 2p increases anonymity set even further, so his idea was doing ECDSA 2p. Then he was like then talking about how you can route Coinswap, like Alice to Bob to Carol to Dennis to Alice back again. In that way, everybody is like, it's not like Alice is paying somebody, but Alice is like churning his coins in such a way to himself that he is gaining privacy. Almost feels like coin join in this light, right? And a swap happens in with this symbol, like this is the symbol that is like used in various places in the document. And swap happens, so this is like Alice and Bob is doing a swap, Bob and Charlie is doing a swap, Charlie and Dave is doing a swap, and Dennis and Alice is at the end doing a swap. Then he was talking about various other kind of advanced UTXO management ideas. Like this was like not a new idea as the same, like you can do this with existing wallet today. But the problem is like the thing is like doing it in this way, in this kind of like hop pattern, will like and will like break the traceability between your UTXOs here and your UTXO here. And that's quite nice, and that's an interesting property. And then you can do the reverse of it. If you have like small chunks of UTXOs, you can like combine them together in a larger way and still like break traceability in the middle. And then he went into other ideas that you need in order to make the protocol like not secure but robust. The protocol has like a lot of mechanism in which like the maker especially can make takers' life very hard by doing all sorts of nasty things. So he came up with this idea of fidelity bonds, and fidelity bonds are ways of kind of like a fraud-proof mechanism on Bitcoin that you can do. And fidelity bonds are used in various places, join market. You can use in you can use in any distributed reputation building mechanism, and that's what a fidelity means. It's a bond that asserts your reputation in a specific database or a specific graph. And then he goes into details about many things. It's a long post. It got few comments from various developers, and it was like it is quite popular, and a lot of people have been taking part into this discussion. And then he went on even more serious, and he wrote the first implementation in Rust, and the development started in 2020. And then that was like the first demo of like how the protocol runs, how the protocol manages all these things, and yeah, a bit of developer documentation. So that's mostly the historical pedagogy. There is another development of that story where it's a bit of sad, but we'll go next. So we have a question, and it's from Iffy. Yes, go ahead, please.
Hey Raj, will you cover fidelity in more detail in the next session, or should I ask question here?
Fidelity, more detail in the next section. I didn't had it in my notes, but okay, like I'll try. We should. It's an interesting concept, and just to like broadly, it's like you are saying like, hey, I own these UTXOs on chain, and my ID, my internet ID, is associated with this UTXO, and if I do anything bad, you can ban these UTXOs and tell other people not to use these UTXOs or any ID associated with this UTXO. So I am putting a cost on myself that I can prove to public, or anybody can prove to public, that it's my UTXO, and if I do something bad, nobody does business with me. And that's a bond. That's like, it's just putting a Bitcoin UTXO out there and associating it with some data. That's the fidelity bond in a nutshell.
Okay, so if you're covering this topic maybe for the next session, there are a couple of questions from our side. The reputation algorithm, is it different than the Oracle? Or maybe Oracle has the same problem, right? Reputation problem there. So first, I think that's how to determine that. The second thing is, if we are banning something, is it something like that the makers, there's some grading system over there, and then taker will first take those in account before making a communication with them, or
Right.
establish? Yeah. Okay.
Yeah. Okay, yeah,
And
good questions. And for the first one, yeah, like I'll go probably in details in the next session. But for the first one, here the idea is like you don't actually have the Oracle problem in Bitcoin, because Bitcoin is the Oracle, and you use the UTXO set, which is a database where if you need to make changes, you need to put cost. So here the argument is, it's not like you cannot repeat. You can repeat fidelity bonds, but that doesn't become a DOS vector, because you have cost associated with each repetition. And that's how we answer the question of like, you don't need to trust the Oracle, you just need to trust the Bitcoin protocol, and in turn that's the Oracle. And and the argument over there falls on top of like, okay, so as long as making Bitcoin UTXOs, unique identifiable separate Bitcoin UTXOs, are costly, nobody can exploit it or create like bots out of this thing, right? Because you have, if it's not effective as a DOS if you just have 3 UTXOs. You need to have like hundreds of UTXOs and allow banning on each one of them. And then like, if the second part of the question nicely fits into it, is like, how does the taker know? Now that's about the implementation details. You can implement it in various ways. You can implement a gossip network between takers, where the takers are constantly telling each other about the bad networks. You can have like servers who are creating like maintaining public database of good makers and bad makers and creating rating system out of it via various like reports these takers are throwing to these servers about these fidelity bonds. Does
Okay,
that
so
answer the question?
it does. So I'm just attaching another question for you, maybe for the next session.
Right.
Uh, um, what is it for example, if I'm a maker now and I have
Mm-hmm.
10 bitcoins and I lock that Bitcoin for maybe a year,
Mm-hmm.
right?
Right. Yeah.
That is a fidelity, right? So
That is a fidelity. Yeah.
what's based on the price differential right now? A
Right.
year ago, 22, I think 22, right now is 37, right?
Right. Yeah.
What is the incentive for me to log that much amount in this protocol? Because I think fee is very minimal in this case. So
Yeah,
just
so that's
this-
one of those questions that you cannot hard answer because this depends on the market conditions, price of Bitcoin, how many people are doing the swaps, what is the market demand, what is the market density, and all these kind of things. So the way it will work is like each taker will have a policy, maybe like the first deployment where there is a default policy where the taker will say like this is the minimum bond that I accept, and as Bitcoin price goes, the market force will allow makers to have like like lower bonds, and if it's too lower, maybe like there is a safe default, but it's not determinable in that way because it's market forces. So um it won't be 10 BTC, it won't be 1 sats also. It will be probably an UTXO is like your guess of how much the maker can benefit by doing one single bad behavior on a taker, and what's the cost of that malice. If that's 1,000 satoshi, then you as a taker will be okay to do 1,000 satoshi 1,000 satoshi fidelity bond, right? And then the other side of the market force will come into picture is like maker will not like have any incentive to increase their fidelity bond voluntarily above a minimum threshold below which like the takers won't accept. It's kind of like the same fee rate, 1 sats per byte. You can theoretically set less than that, but nobody will accept your transaction if you do that. Same kind of mechanism can happen over here, but at the same time the upper boundary is will be the market equilibrium. It's kind of like how the shopkeepers like set their price. You do not want to set like too much above others, you do not want to do too below above others. You want to try to find out what's the market equilibrium and the market rate going on. And there a lot of other kind of infrastructure will come into picture. It's not just one software. You will have like this kind of, you will need to have this kind of like bulletin boards. You will need to have some kind of like gossip network. Like that's the hardest part, and that is not implemented yet in order to have this. So far, what in the start, the taker will have a default below which they won't accept, and the maker can set that as their like starting point of fidelity.
okay. So do you have room for one more question?
Yes, sure.
Okay. So is it? I think my point is the economic value of locking Bitcoin for a longer period is basically sometimes painful for the
Hmm.
maker. Can we?
Because it's a sunken cost. Yeah.
Yeah. So can we replace this with proof of reserve?
Proof
If
of reserve. I
the
mean,
idea the idea is to establish some sort of reputation system, right? The baseline is that.
yeah, like it is a form of proof of reserve. It's the same thing. Like fidelity bonds and proof of reserves are not very different. They're the same thing. They're like Bitcoin transaction. You are proving that you own these UTXOs and you hold the private keys of these UTXOs. There the argument is a bit different. Is like it's more about knowing and proving that you have ownership than
Okay.
like attaching to a reputation. Here it's more about attaching to a reputation. So same concept, but with reputation you have fidelity bonds.
Okay, but I think in proof of reserve, we have this as a maker, have this luxury to not lock. We can prove that this is the owner, we own this for that much longer time, but based on the market condition, we can also exit. But the reputation will change. But over here is we are locking for a very longer, maybe a little bit longer time.
I mean, who
That
changes the reputation then, and who checks that where it moved? That's a question that you need to answer also with that, right? Because if you move the coins, then somebody else owns the ownership. Then you can do another proof of reserve that yeah, it's still me that's owning the ownership, but then if it's just the same UTXO and the ownership is same, why do you even bother moving? Moving makes sense when you're sending from A to B. But with Fidelity, you are attaching reputation with A having a coin at that point in the UTXO graph. So you cannot just move it. And I don't see how proof of reserve fixes that.
Yeah, because the reason I asked this question is we have very similar problem with the exchanges.
Mm-hmm.
The exchanges have to prove that at some point they have enough liquidity in them.
Mm-hmm.
So so they that's why they rely on proof of reserve, and the proof of reserve, there are many ways of solving this problem, that they own the assets that they are betting against. So anyways, I will wait for the next session. Thank you.
Okay, cool. Yep, yep. Well, we'll go in detail about the next section. Okay, so that's the anecdote. The last stuff was unfortunately Belcher got really sick in a long COVID situation, and this was he was maintaining a public diary where he was like keeping track of all the work, and his last entry was like he basically declared that he cannot work on the project anymore because he has like going through some hard, difficult um, health situation. So the project was halted from this original GitHub repo, and then it was last commit was in July 3, 2022, right? So that was the historic anecdote, and we later on started working on that implementation and developed a bit further. So now we will go on to the theory part of it, the theory part being like the mechanism, how it actually works. Will basically do almost like half lightning. So it will be fun if you are already going through lightning sessions or lightning read somewhere. It will be fun for you to follow. But before that, any last round of question on this part so far?
Just for everyone, if we can talk about like what's teleport specifically and how is it related to Coinswap?
What's teleport specifically, and how, like you're saying like Bitcoin teleport?
Yeah.
So that was the name of the project. So he called it teleport transactions. Like that was the name of the library. That was the name of the project, teleport transaction. But it's basically a Coinswap implementation. And Coinswap is just the name that was used in the first post. That was the title of Coinswap. So people know this as Coinswap. That's the link between teleport and Coinswap.
Okay.
Cool. So for the next part, we will delve into the theory, and here I'll slideshow because I don't need to change a lot, but it's better if it's bigger. And we will talk about a swap, the most simplest kind of swap that you can do between two parties, Alice and Bob. And it's you can like at this stage you can almost change it to Lightning channel open, and this will exactly how it will look like, except this last step. So up to this part is exact Lightning channel open. So a Lightning channel looks like this, or swap funding transaction or the funding event looks like this, or you can call it the swap establishment event. So Alice creates a funding transaction, and Bob also creates a funding transaction. This is the first transaction Alice makes. Alice has some UTXOs. He creates a transaction called a funding transaction. Bob has some UTXO, creates a transaction called a funding transaction. These funding transactions are related in some interesting way. That is like the first funding transaction has signature from Alice because it only spends from Alice's UTXO, and it has output to a 2 of 2 multisig. that is owned by Alice and Bob together. So this output is a P2WSH 2 of 2 multisig, same old stuffs. And Bob does the same thing. Bob creates a funding transaction, Bob's signature, Bob's UTX. So Bob creates an output, again Alice and Bob 2 of 2 multisig. Then he create Alice and Bob, they both create another transaction which is called a contract transaction. And this contract transaction is like, it should be in dotted line because this contract transaction in ideal case is never in the blockchain. If you do not publish this transaction, it's called contract because it kind of like works like a mathematical contract. And what you do with this transaction is like enforce that Bob cannot cheat on you. And Bob does the same thing with you. Bob creates a contract that enforces that Alice cannot cheat on Bob, right? And then both Bob and Alice signs the contract. It's almost same as signing a legal document, right? You have the transaction, both Alice and Bob signs the contract. So the flow looks like this, and just to complete, like the contract transaction looks like this. It has an input that has both Alice and Bob's signature, and it has two output, and this is called an HTLC, hashed time locked contract, because two of them output, one output is time lock, another output is a hash lock. And probably we will go later details more on time lock or hash lock, but maybe not. But check out any Lightning book, Mastering Lightning, and or any, like, search up in Google what time lock and hash lock transaction looks like, and that's the same thing. So there are a ton of resources because of Lightning on time locks and hash locks and how exact this output format look like. And this kind of structure is called an HTLC, hash time locked contract. So it's a contract which is hashed and time locked. Why we do that? Because we wanna do basically this, what I'm gonna explain next. So Bob does the same thing, creates a contract, Alice signs, Bob signs, and the output. So now if you look at the outputs, you can see like they are symmetrically opposite. Here in the Alice's contract transaction, time lock to Alice, but hash lock to Bob. Bob's contract transaction, time lock to Bob, hash lock to Alice. That means if Bob can open the hash lock, then Bob gets the fund of this contract. If Alice can open the hash lock, then Alice gets the fund of this contract. If that's the happy path. In the sad path, where like Bob does something nasty, Alice takes her coin back via the time lock, Bob gets her coin back via time lock, right? So uh, before this time lock expires, this hash lock mechanism has to go through and people have ownership of their coin, so they wholly own contract transaction with each other. That's the contract, right? And this contract spends from the 2 of 2 multisig of this funding transaction. Because we want to sign two-way in the contract, that's why this is a 2 of 2 multisig. Alice is committing an amount to a account or to a vault which is owned by Alice and Bob together, and just by creating that transaction, Bob doesn't get the fund, right? Because Bob doesn't have Alice's signature to get through this contract transaction. But wait, here's a catch. The problem is Alice needs to get the contract transaction signed before he publishes the funding transaction. Can you see why? Because without this signature from Bob, if Alice publishes the funding transaction and it gets confirmed, Alice's fund is locked and Bob disappears, and Alice is like lost his fund because it's in a 2 of 2 multisig that he doesn't have whole access to. He only have whole access to this UTXO via contract through this time lock, right? That means like this contract has to be a valid transaction. That means he first needs to get the signature from the Bob. So the workflow goes like Alice creates this whole thing together, like both the funding and the contract transaction. Bob creates the whole thing together, both the funding and the contract transaction. They can unanimously and the local node create it, because Bob will tell Alice what will be his public key here, and Alice will tell Bob what will be his public key here. And then Alice will create this transaction and send it to Bob and say like, give me a signature, then I'm talking. Bob will do the same thing. Yeah, give me your signature, then I'm talking. Then they will sign each other's contract transaction, send it back. Then Alice will check, she's happy, and then Alice will broadcast the funding transaction. Note, the contract transaction will still not be broadcasted, only the funding transaction will get broadcasted. And to make the funding transaction safe and already have the recovery path, you need to have the contract transaction signed. So this is like the off-chain part of the protocol where there is a pre-signed transaction happening, and that's why like it's a very confusing thing. Like it also seems like off-chain protocol because Lightning, you call it as a off-chain protocol, and Lightning also does the same thing. This same mechanism happens for Lightning. Up till this part is exactly the same as Lightning. So this is how the contract establishment happen. When everybody happy, they publishes their funding transaction. Funding transaction then get confirmed. Then they do something funny, and that is where it differs from the Lightning Network. So far, like I'll take a pause. Questions, thoughts, anything? Yes, Basanto, go ahead.
Yeah, so I have three small questions. So in this case, when you have Alice and Bob, so there are going to be 4 total transactions, if I'm understanding it correctly.
2 on-chain transaction if things goes well, 4 total transaction if things goes bad. Yeah, there will be 4 total transaction if things goes bad. That means you have to go through the contract transaction.
But a total of 4 will be created regardless. Like only 2 will be
Regardless,
published.
total or 4 will be created between 2 parties. Yes, in fact, like in the implementation, they will create a bunch of them. It's not one funding transaction, they will create a series of funding transactions for various reasons that we'll see there later.
Okay, second two are kind of theoretical and speculative, but so we have Cgash any previous output, right? That is being proposed as a way to scale make Lightning more symmetrical. So will it apply in this case as well, where the outputs like the penalty transfer or whatever you call them, the contract HTLCs that are being created, is it like applicable here as well? Will it make it symmetrical, both the HTLCs?
That's a good question. Unfortunately, I don't know because I don't fully understand how SIG has any previous output like scales Lightning. That's just my block of like gap of understanding. I just don't know. So I haven't like understood those details, and so my guess would be, yeah, probably like many kind of improvements that we can do for Lightning channel opening can be done for this thing also in theory. Yeah. Okay, two people want to speak. Does that answer question? Further question from you, Basanta?
No, that's
Okay. Okay, Bala, go ahead.
Yeah, how does the communication happen? If the transactions are not broadcasted,
Right. So
does it?
like Alice and Bob will have an watch on the Bitcoin blockchain. Alice and Bob will have an internet connection between each other. So that's how the communication happen. So yeah, like just how like any other peer-to-peer communication happen. For example, Lightning. You need an eye on the blockchain. You need a connection between two guys who are talking, an active connection where you're listening. If they are not replying, then something went bad and you need to do stuffs about it and all this kind of thing. So it's a very live kind of network. Yeah.
Oh,
But they fall off
by
once the swap is done, once their work is done, then they fall off. Like then you break this internet connection, and it's not like Lightning in that sense. Like you don't have like a 24/7 running node. For makers, yeah. For taker clients as a user, you don't.
okay. So it is as a part of the implementation stack, the communication is also included.
Yeah. Part of the
Okay.
implementation. Yes. Okay, Iffy.
Sorry. I'm just repeating what you just said, just for confirmation of my understanding. Let's say Alice and Bob, both, in order to implement this thing or understand this thing, both must have a public key, right? So
Yes.
and then they share with each other just to establish 2 of 2 multisig
Yes. Yeah.
through some offline protocol, right?
Yeah.
And
Right.
then once we have that, both can commit those transactions to a safe multi-sig transaction online
Yeah.
on the channel. Once that's there,
Yeah.
but through some observation mechanism, watchtowers, they can now create a contract transactions, which is HTLCs, right?
No, like they already create the contract transaction, get it signed, and get done with it before they go on chain, right? So
Okay.
without a signed contract transaction, they don't move ahead,
Okay. Got it.
right?
Thank you.
And then, like, if everything goes okay, they only hit one, like, in theory, they only hit the funding transaction on chain and nothing else, right? And everything else happens off chain, like in their private network, like private internet connection.
Thank you.
Yeah. Okay. Fellow Gister.
The 2 funding transactions, they don't have to be published at the same time. It could be hours or days in between. Because they are disjoint, like you're trying to create.
Yeah, it's a good
Non-linkable.
question in the sense, like, they don't have to. Like, yeah, they don't have to. They can take a gap between each other. They don't have to be simultaneous. In fact, it's better if they are not simultaneous for privacy reasons. And but like they both will, like, one part, whoever goes first is the one who wants the other person to go as that, right? So if you have already done your funding transaction, you don't want to wait much because you want to get it done because your funds are locked, right? And going through time lock is cost for you, so you want to get it done. It's like a trade, you're gonna get it done as that, right? So after the funding transaction initiated, like there is some I don't think it's implemented in the protocol yet, but like in the implementation yet, but there could be some random gaps, but it cannot be like 24 hours. That by that time, Alice will already like presume something went wrong or Bob is not coming back or something and try to like get his coin back via time lock.
And can you link them by amount? I guess you could see the amounts or like, yeah.
Yeah, you can link them via mount, and that's a problem that was already documented and thought of by. We'll talk about it also in next part. There we do like random breaking of the UTXOs. So you instead of like creating like same amount of coins, you can do a lot of things. You can do pay join with it to break that, and you can do a lot of interesting things. But yeah, amount correlation is an attack, and there are ways to fix it.
And a final question. So it's very important that you get the contract TX from the other party before you sign your own and send off your own. And I was wondering, like, if you're using experimental software like this and there's a bug, like, what are tools that you can use to convince yourself that you have in fact, like, how can you sort of simulate that you have the contract transaction if you are afraid that the software, so it's like, you know, could you open the contract transaction in Sparrow, or is there some other way to sort of simulate that you know that the contract transaction will actually execute and that you don't have a buggy contract transaction? It's a high level question.
Yeah, I mean that goes into the high level of like how this protocol interacts with the user space, and I personally feel something like that should exist. You should be able to like properly check the contract transaction in your hardware wallet or like some wallet that allows you to do that. Currently, the implementation isn't at that level where we can implement that, but I see like, yeah, that can be done and that should be done. And the automated way how we do it is like we write like for one thing is like you can self-verify because it's a Bitcoin transaction. You can self-verify whether you have it or not, right? So in the protocol, you cannot trick the code that you have a right transaction without not having the right transaction, because the code will go and check in the blockchain. Now, that's by the protocol. Like if the code is right, if the code is not right, then it can do anything, right? Then you don't know. And I don't know how to answer that via software. The answer is like you have the protocol, the entire thing in open source, so everybody knows what the code is doing, and you have like tests that is like asserting not only this, but all the other kind of bad things that can happen in the protocol, right? And and yeah, I guess like that's a open like question for like any software in general.
It's a good answer. There's like the validating Lightning Signer project for Lightning. So I was thinking maybe you could do something like the
I
same
mean, like
for
that
this.
sounds like something very useful over here. Watchtower is something very useful over here. So far, how I have been trying to designing it is like I was trying to do it without Watchtower. So both Alice and Bob is like as sovereign as possible without like relying on any third-party service, just having an internet and an eye on blockchain. And then they like then they obviously like the code has to run correctly to know that you have the contract transaction. But once you have the contract transaction, there is not much way people can take your money, right? So like even if Bob disappears, you get your money back after a few days.
I have one final quick question for this slide, and it is, so it's just on-chain, this will appear as a normal 2 of 2 multisig. So that means that if we get improvements where 2 of 2 multisigs can be done through Taproot, like
Yes, exactly.
then
Right.
it should look as just a 1 of 1 normal
Yeah.
signature, and you can't even tell the
Yeah.
difference.
Yeah, totally. And that's one part of our roadmap. And that's just obvious. It's just 2 of 2 P2WSH multisig at this prototype level. But there are like so many other things that we can do. There are some ideas about adopter signature that we can use inside Taproot in such a way like you don't need to create a separate contract transaction. The nice thing about Taproot is like you can combine funding and contract transaction into one single transaction. And depending on what happens, you spend the funding transaction in various different ways, right? So yeah, there are like many improvements with Taproot. Music too, of course, because why 2 of 2 multisig when you can do Taproot music? And then adopter signatures. Nice thing over there here, our anon set is like 2 of 2 multisig, which is not much great apart from like lightning fundings. And then with Taproot, we can hide with the BRC20 regions, right? So like previously when Belcher was like Belcher also had a thought on this, and he was like I talked about this in briefly in the design. So this was interesting. Sorry, not this one. Um, so he talked about ECDSA 2P, and his idea of getting into the single sig anon set was like we use ECDSA 2P, and why not Music 2? Once was like back in 2020, Music 2 wasn't developed, and why not Taproot? Taproot didn't had enough anon set, or like when he was working on it, Taproot wasn't fully deployed, right? So he went for ECDSA 2P, but like I when like copying his roadmap, I kind of like dropped that plan because now we have Taproot. I guess that answers questions in elaborate. It's just a very good question. I wanted to talk about it.
Thank you.
Awesome. Okay. Okay, Ify, go ahead.
I think this question is for the second session. At some point, will you discuss the whole ecosystem in terms of the infrastructure? I think we talk about the watchtower, we talk about the wallets, and then what else that if somebody is building this from the infrastructure side, can you maybe describe those maybe as some sort of simulations that just
Right.
like Lightning, in order to deploy that, there is some infrastructure that has to be in place, right?
I mean, like I had a slide for this on later part, like much later. I don't know, like definitely will not be able to reach there, but it's called deployment strategy. And
Okay.
the way you do it is like the simple idea for deployment of this is like you turn the maker into a server that you can run in any node software, say MyNode, Umbrel, Star9, whatever, any node software where you can install it like an app. You can run a maker server, and the maker server is like a black box where you just run it in your node, put some sats in it, and it earns fees for you. and it earns fees more passively than Lightning, because unlike Lightning, you don't have to actively maintain Maker server. You just have to fund it enough, secure it well, and that's it. And it just talks in internet and it makes ads for you. So it's a nice app to have in App Store. So that's our plan for deployment. And then you can turn the Taker into a wallet plugin. Like you can put the Taker as a feature in Sparrow. You can put it in mobile wallets, Samurai, whatever. We haven't decided like how to deploy it in as a wallet, but what we'll aim for from our side of the infrastructure is like there will be a Rust library API that will have like FFI bindings into Flutters and React Native, and then you can like integrate that as a feature inside whatever wallet app, right? So we'll try to make a demo, maybe a small web app on how it looks like, but eventually like those are the place where like proper wallets, they can add it as a feature. Our task is to just to make the API as robust, as secure as possible, and that's what the current Coinswap project is.
Okay. And so Bitcoin is a niche market. Lightning is further niche. I think Coinswap is
For even nicher.
yeah. So if the makers are taking it's not active taking a fee out, so how do you sustain this project then? What is the economic value of having
I
these
mean,
fees?
like if you have some sats lying around, it doesn't take a lot to run CoinSwap makers. That's the good thing about it, rather than CoinJoin. In CoinJoin servers, you have to have a lot of, you don't have to have a lot of liquidity. The servers doesn't need liquidity, but you have like this centralization where the server acts as a coordinator. Um, here you don't need to put a lot amount, so I don't see like how it will turn as a big business. In fact, my hunch is like it won't. What will happen is like home node runners will like put like 50,000 sats in it, like just how people run Lightning. And if people are running Lightning in their home, they can definitely run maker servers in their home much cheaper, in a much more passive way, and that's enough to provide privacy for rest of the people. So if there are like 10 makers providing swaps, that's enough for a lot of clients out there. So you also don't need a lot of people running makers.
Okay. Maybe a discussion for later, business strategy for such projects, maybe later, so not now.
Yeah. Probably those are better later.
Okay, thank you.
So we have a question in chat. What item does Alice has to create the hash lock? I suppose in future Bob will somehow learn this pre-image to spend it. Exactly, like that's what we'll do. Like Alice will create a pre-image, and at later point Bob will learn the pre-image. With learning the pre-image, Bob can open the hash lock and gets this coin. Same thing for Alice. And it's the same thing. So this also happens in Lightning. So you have pre-images, and those are called payment pre-images, and that's how you, for each payments you create a pre-image. That's where you lock the HTLC, and you settle the HTLC by showing the pre-image to each other. It's the same thing. So here's a bit farther into the theory. This is like, up till this, the pre-image part is same as Lightning. Now they do something else. Instead of showing each other the pre-image, what Alice does is like Alice sends the signature of this 2 of 2 multisig to Bob. And Bob does the same. Bob sends his signature to 2 of 2 multisig to Alice. Effect of this is Alice now unanimously own this output. Bob now unanimously own this output. And that's the swap. So at the end of the swap, it's not even a signature. Sorry, I have it wrong over here. I should correct it. It's oh, this is an image. I'll correct it later. This is a private key. It's not even a signature. Alice directly gives the private key to Bob, so Bob can produce signature unanimously for Alice. There is a way for Alice not to give private key, but give some adapter signature. And in the adapter signature way, it's even more compact. The transaction size is less, but it's a bit more complex. So that's why you don't have it like we need to spend a lot of time thinking about it. But in this multi-sig case, it's just a private key handover after the establishment of the contract. So Alice puts funding, Alice gets contract transaction signed. The very next steps, Alice goes to Bob and say, hey, here's my private key. So you never have to use your contract transaction. You can just directly send my output. Bob does the same to Alice. Here, they have some extra steps and some extra mechanism in a way to make it atomic, in such that like Alice gives the key to Bob and Bob then runs away, then Alice is in trouble. You cannot allow that to happen. So that's where like the communication protocol comes in, and this is, we talk about it a bit here in this part, and this is also part of the developer documentation. We also documented it in code very clearly. One thing in Rust is like you can write code very clearly, so it's very easy to read. So this is how the protocol documentation look like, but I don't want to go into too much detail on this because there is some part of basic theory still to cover. We are already at 1 hour mark. We plan to stop this at hard at 1.5. So we have 30 more minutes. I will try to cover as much as possible. Whatever left out, we'll cover in the second season. So far, any further question on this? Yes, Basanta, go ahead.
I don't know if you have covered it already. I joined a little bit late, but is there any plans of a multi-party swap kind of thing? So three people come together, they create three funding transactions, something like that.
That's our next slide. Thanks for asking the question.
Okay.
Multi-party swap.
No,
Nice.
but this one is like kind of like a channel, right? It's a going from
Yeah,
one person to the
yeah,
next one.
yeah, yeah. It almost like something passing from one people to another. Not exactly, but yeah, you can think about it. It's a good mental model to think about it.
Okay,
But
but
there is
can
no
we have
payment
something
happening.
like
I mean, yeah, like you can have a payment happening. Like you can, it's trivial. Like if you don't do this part, then it's a payment from Alice to Bob to Carol to Dave, which is a lightning payment. But
mm,
it's not a very efficient lightning payment because every time you are paying Dev, you are making one on-chain here, on one-chain here, one on-chain here. Now that's not a smart lightning thing to do, right? You don't want to go anything on-chain once the payment channel is established, but here the contracts are ephemeral. Like the payment channel goes away the moment the swap is done. The moment and swap is done, Alice and like there is no connection between Alice and Bob anymore. Alice is a free particle after that. So also in that way, it's not like a dynamic thing. It's a more of a static thing. So that makes the protocol much more simpler than Lightning because you don't have to maintain anything live, right? So even if you go away, like if you stop running your maker server, nothing bad happens. You just close your shop on that day, right? So the liveliness requirement of this is much lesser in clients. In mobile apps, it's even much lesser. You don't have to keep running your mobile. You don't have to like run a big node or something. You can do it with light clients, BIP 157, Neutrino kind of thing, and it can be self-sovereign, like all like yeah, like totally in bounded into your mobile, talking to the Bitcoin network and Neutrino, and you don't have to be live, and there is no state that you have to maintain. You can go away freely. Yes. Okay. Thank you. Any more questions? Then we will cover multi-party swap, and then we'll basically open it for a broader general Q&A round for last 20 minutes, and then we'll close it today. So the idea is simple. What we just talked about, what we can do, this is a swap between Alice and Bob. The same thing happening. This is one swap with all those details and funding transaction. Now you can think of as a swap, like something's coming and going between Alice and Bob. Then Bob and Carol does the same thing. Carol and Dave does the same thing, and Dave and Alice does the same thing. And who are Bob, Carol, and Dev? They are called makers. So the green ones. The green ones are maker, and Alice is a taker. Why is a taker? Because Alice wants a service, and they are providing a service. What is the service? Swap with me, and give me a swapped coins. So Alice is swapping with Bob and Alice is swapping with Dev. So Alice is getting privacy from Bob, and like Alice giving privacy to Bob and Alice taking privacy from Dev. And in the meantime, you can have Bob and Dev swapping privacy among each other, but you can put any number of nodes. Like you can put a 7-path channel, 100-path channel in theory. But the problem is higher the hops, higher the cost, because these are service providers, so they will not pay fees. Why? They are putting their fidelity bonds, so they are putting their cost. They are online 24/7. They're burning electricity. They have like SATs liquidity locked in that they cannot use. So they have cost, and these transactions they take cost. These funding transaction establishment, they take cost. So somebody has to pay for it. Who pays? Alice is a taker. What Alice gains is like Alice does not have to like be online. Alice does not have to put a lot of money. Alice just says like, hey, I have 100 UTXOs. I want another 100 UTXOs in exchange of it. And they perform a swap with Alice in this. In our code, inside the code structure, as when we go code review, we'll see that this is called an outgoing swap coin or an outgoing swap. Why? Because from the taker's perspective, this swap is going outward, and this is called an incoming swap because from the taker perspective, this is a swap coming inside. And the same thing from happening from Bob's perspective. This is an outgoing swap. This is an incoming swap. For Carol, this is an incoming swap, this is an outgoing swap. For Dev, this is an incoming swap, this is an outgoing swap. A bit technical insight in actual communication. Bob and Carol does not talk with each other. Bob doesn't even know what Carol is. Like he knows his public key, but he doesn't know his internet address. Bob doesn't definitely know who Dave is, or there is even a Dave exists. So the privacy over there is like the very same as Lightning, where you only know your immediate hop and their public key and internet communication, internet address, and nothing else. So Bob doesn't know there is a Dave exists, and the communication technically it happens between Bob and Alice, Carol and Alice, and Dave and Alice. And when in this dance is going on, Alice works as a relay between Bob, Carol, and Dave. Right? So Bob doesn't directly talk to Alice. Whatever Bob needs to say to Carol, Bob sends to Alice, Alice sends to Carol. Carol sends to Alice, Alice sends to Dev, and Alice becomes that temporary relay between Bob, Carol, and Dev. Right? So yeah, many questions. Let's take Bala first. Yes.
Yeah, in CoinJoin, you are assured of forward-looking privacy. In
Right.
the case of swaps, I'm not able to clearly understand. Does it offer you forward-looking, or
The
does
opposite
it
of
also
that.
offer you?
It's called the backward-looking privacy. So what happens, the privacy you gain in swap is if you look backward, you do not have a heuristics to fall back on. That's what happens, and that has privacy implications also. So it's very different in terms of like the flavor of privacy, because you can still trace coins, like you can still see transactions going through in blockchain. You just
Yeah.
don't know who ends up with what.
Pools.
Yeah,
Okay. So if Alice and Bob swap a coin, the chain analysis cannot say that whatever Bob has is Bob's and Alice has is Alice.
exactly. Yeah.
Yeah. Okay.
Yeah. Okay, so that's the multi-party swap. And then like a bit of we can cover this part also. So this is the detail of the communication that happens. So this is Alice, Bob, Charlie, Dennis, and later on there is an Alice, but this is not shown in that table. And if you follow through these communications, these are marked with different numbers, and we have a corresponding message sequence inside our code, and this is all documented in the developer docs. So if you go to our repo, So we have all the docs listed in the developer. So this is the mailing list, this is the detailed design, this is the developer docs, and developer docs is like the doc taken from Chris Belcher's README, then added extra on top of it as the development progress, and it has some a bit of details on protocol, the exact protocol, the communication, the message, and the details of those messages that happens between a taker and a maker, right? And they are categorized into two parts: a taker to maker message, a maker to taker message. This is the message that makers, so this is like this part of the things the maker sends to, like Bob sends to Alice, Carol sends to Alice, Dev sends to Alice. And this is a taker to maker message, and that's the corresponding, like the corresponding thing that Alice says to Bob, Alice says to Carol, Alice says to Dev. And there are only two kind of messages, because there are only, actually the communication is a hub and spoke model. Like Alice is the hub, everybody else is spoke. They don't talk between each other, they only talk to Alice. And there are like various kind of details, like here this one is like sending the hash pre-image, this one is sending the last private key handover. Like we still send the hash pre-image in case that the last private key handover fails, so they have the hash pre-image to recover from. And then we send contract 6, we send proof of funding, we send contract 6 for receiver and sender. The name of these messages like has changed a lot historically through the code base. I tried to like make it as clear as possible. Some of them are response and some of them are requests. That means like some of them are an ask and some of them are they are an answer, right? And you can look into the code base. They have the link into the source.messages.rs. This is where the message, this protocol communication is also listed in terms of like the code messages, the actual code objects, which who sends to whom at what. And for an example of a two maker swap, so there is a maker 1 and maker 2, and taker to maker 1 to maker 2 to taker. And this is how the message sending looks like. A few bit more technical details where exactly this thing is happening is inside this file. There is a file called taker protocol, and taker protocol has this function called send Coinswap. And if you look at this function, it's not very big. No, it's a function. Yeah, it's not very big. From this line to this loop. Is it this big, or we are into different function already? So yeah, send Coinswap starts over here. I think it's cargo FMT that made it so big. But yeah, like there are like single lines with like because Rust, it looks like a big thing, but it's like very simple line. And settle also and Coinswap, that happens, and then here it closes. And like it's 100 line of code around, and there you will see like this message communication taking place. Gonna take some time to sit through, and so this entire process is happening on that loop. And everything else we'll see like what each of these other folders and modules contain. Everything else are different modules for doing different things, right? So yeah, we were at here, and this is the final communication, and I guess that's what I had to say. We have last 10 more minutes, so let's open it for like open questions. Ify, yeah, go ahead.
I think this communication steps are different for the next session. Okay.
Like the communication steps, I won't go through the communication steps in details even in the next session. That's not useful. You can read through them on your own. I'll go through some more advanced theoretical ideas where we are doing UTXO splats, like splits and joins, some ideas on pjoin. Then we'll talk about the current projects and its roadmap a bit. Then we'll talk a bit about the code structure, and we will do a deep dive through in the code structure, but the way it's going, we'll see if we reach there in the next one. and then we have a demo, and we could do the demo today because it does not take a lot of time.
Okay.
Yeah, so I would really like if I can have demo before more theory,
Okay,
because like it will be easier
let's
for
do
me
one
to.
thing because it's very simple for me to run the demo, and I wanna run a case that is like a very bad, where you will see like the maker did something bad, and the takers are like aborting. Um, So here what happens is like maker closes connection after receiving a signature for sender in middle of the protocol and doesn't broadcast its funding transaction. So here the story goes like the maker was supposed to broadcast a funding transaction and he doesn't. And in the middle of a protocol, and this is a bit problematic case in terms of like blamability. You cannot really know like which maker actually broadcasted the contract transaction because they have like the same version of the contract transaction, and there are certain ways like you can do to identify which maker did it, but that is not implemented yet. So I'll run this test and it will keep running. It will take some time, and in the meantime we will have questions and we will go and check through the log of what the communication happened, and you will be able to understand what happened. It's not much useful to keep checking it. Fuck, it's building Bitcoin D. That's gonna take some time, but we'll keep it running and have questions in between. Yeah, EMJ, you have some question?
Yeah. So one question I had is like, I guess first of all, yeah, swaps between two people don't make sense, right? They don't give any privacy. So when
Yeah,
we do
yeah,
when we do multi-party, I think so.
yeah.
Let's say there's a public like Alice and Bob. Bob will give one public key. So Bob has to make sure that the public key he gives for Bob and Carol is different from Alice and Bob, and that those two public keys cannot be traced back to the same person, right?
Oh, come again, like Bob has to ensure that the public key Bob gives to Carol is different from Alice.
Right, right.
Yeah, yeah,
Because
yeah, definitely. Like,
otherwise
yeah,
you can make you
you can
can
link
trace the
them. Yeah,
chain.
like that
Yeah,
would be stupid if you share the public, if you do the same public. Yeah, yeah, definitely not. Every time they do different public key to different people.
right. And also, so but the thing is, if Bob is bad with his privacy, it still can be linked. But then, yeah, you would have to go trace
Mm,
Bob's. Yeah,
yeah, I mean, like if Bob licks his ex-pub, then Alice is in a problem. Yeah,
right, right.
yeah.
Yeah. So we're dependent on makers being
Yeah,
uh,
yeah,
yeah,
robust
good with their
makers. Yeah,
privacy.
yeah,
Yes.
robust makers. Yeah, good with their privacy. Yeah, if like if you lose your watch only, then why are you even trying to do privacy? Like you should never lose your watch only, right?
No,
So
but there are other heuristics to understand if it's the same, right?
yeah,
I think,
yeah, yeah,
yeah,
yeah. There are
spending from the
yeah,
same
like
input. Yeah,
there are other ways to correlate. One is timing and another is amount. So yeah,
right.
those are more complicated and needs to be handled. Okay, our fellow Jitster.
High level question. So there's Bolt's exchange, which is like a trustless sort of swap thing for Lightning. And I was thinking, like this whole protocol, how would it how would it be different than, or could it be replaced by, or let's say like you create a private Lightning channel to somebody, and then you ask them to make payments for you on chain. So, but in a that would also sort of make a disjoint between the two UTXOs. So you would break the linkage between the two, and you would. So could you get this
Yeah.
sort of protocol for free through
I
Lightning?
I mean exactly what I thought, right? You can like add this mechanism just as like a prelude or like a extension of a lightning channel, right? It's not much. It's the same HTLCs between Bob and Carol, but here like a lightning channel doesn't help much because you kind of have to create a funding transaction every time you're doing a swap. So, but anybody who has a lightning channel between them, there's no reason they cannot do a swap at like with each other, right? So they are also like swap partners. So you can use the existing lightning payment paths to leverage a longer like swap route and in theory that's better privacy, but also like after 3 or 4 it does not increase a lot, so you reach a plateau. Like I don't know how to quantify that, but you in sense you reach a plateau. It doesn't matter if it's 5 or it's 100. So it matters if it's 1 or it's 5, but it doesn't matter if it's 5 or it's 100. So it can be, in theory, be plugged in into a existing Lightning channel totally. But I don't know enough details about the Bolt exchange things to comment on it. I would think there could be overlap. There could be overlap between this protocol into many other things. It's such a simple and established protocol because it's just HTLCs. So in fact, like many of the abort and malice situations are same as Lightning. So our plan
Again,
is
like
to like, yeah, go
again,
ahead.
like a high level example would be like if I open a private Lightning channel to you and you have no other Lightning channels, then we have like a segregated Lightning network, just you and me.
Just between
And
you and
now I
me,
could
yeah.
ask you, please pay on chain to this, and then you would just have to like solve for some way where I could say like a HODL invoice or something like that, where I could this way I could reuse the it would also break the linkage by amount. So
Yeah,
instead of being like
yeah.
a 1-for-1, it could be like I open a channel once and then I do 10 payments, and you can't really tell.
Right,
Yeah,
right.
over time.
Yeah. There are many fun things to be done with this protocol. Like I'm a bit sad why like it didn't got a lot of like broader community attention in terms of like extension. The way it is right now, it's not even its best version, right? It's a very like ghetto version of like doing it, but just to put the idea out there. But you can do a lot of magic on top of it. It's really fun to think. Okay, Iffy?
I think my question is on the heuristic side. Uh, I think when I was reading this, people are talking about, I think it's economically it's not viable to have maybe 10 or 15 people for Coinswap. So people are talking about 4 or 5. So, but how to ensure that the privacy is still maintained if Carol or Dave does not collude together just to I think it's a small system, right? Eventually. So how to make sure that the privacy is still maintained, heuristic element is still maintained for Alice in this ecosystem.
I mean, like, what is happening is like a musical chair, and you can think of it like a certain degree of rotation in the musical chair in such a way that you don't know who is on what chair, and that does not matter whether you have 100 people chair or 10 people chair in that cabal. It's it the breakage of backward privacy is like backward traceability is same, and so you can imagine like multiple cabals like that going on all over the network, and then and you cannot distinguish between like a dance that is happening and there is a normal single sig transaction. So that's the argument. Okay, Faisal, go ahead.
Raj, the taker is the one who pays the mining fees for all the transactions, and he's also the one who pays the makers the
Yeah,
Coinswap fee. So, what
yeah.
would be the incentive for the taker to have a numerous number of people in the chain instead of 3? What would
Not much.
motivate him to have
Yeah.
5 or 7?
No, you won't want. Like that's why like you don't want 100 because that's a lot of fees to pay. And so you want like you I don't know what a good number is. Like there is no way to answer what the good number is. It's like
Like
how
an
big you
equilibrium
wanna.
between privacy and.
I think it's gonna devolve in market. It's good with 3. Some people might wanna choose 5, and eventually we'll see a number that most people are comfortable with. Um, and something like that will happen.
Thanks.
So yeah. And like the effort of the protocol design is to minimize the fees as much as possible for each of the hops, so you can have more hops. So you are not forced to have like very small hops. Very small hops are bad, but too large hops are not too good, right? So you have a moderate number of hops. Somewhere there is a balance, and I don't know the right number. And the with Taproot we can like increase like decrease this a lot. So that's why Taproot is definitely part of the roadmap, not on the beta release, but like not on the alpha release. Sorry, not on the beta release. Alpha release was already done and by Belcher. So on the beta release it won't be, later on in other versions. Yes, Vala, go ahead.
Yeah, in Samurai Wallet right now there is a feature called Ricochet, where
Hmm.
you can add multiple hops between
Yeah,
your
that's not the same thing.
UTXO and
That's
where
not the
you.
same thing.
Okay,
Yeah, it's different thing. Yeah. But like
okay.
that's a bit of extra details in overview. It's like you are just creating self-payment transactions one after another, or maybe not. Like you are just, yeah, you are just creating self-payment transactions one after another. It's like
Yeah,
one
you
guy is
use your
creating
own
a,
UTXO.
yeah. So it's not the same thing as a
Okay,
swap. It's not a swap.
okay, okay, okay.
Okay, we are at the close of today's session. So not next week, week after that, we will announcement and stuffs will come along as usual in usual places. We will go through the advancements, the advanced ideas on this theory, and these are part of the beta roadmap. And pay join, not beta, this will become later, and then we'll talk about the code base a bit. And now we just check, holy shit, like there is a failure. That's bad. uh the failure is wood block. I will just take 5 minutes to see if I can fix this failure. Let's see what happens. Run the test. Okay, it started. So we can follow through. It will be fun to watch. So a Bitcoin D started, and the taker wallet is starting. So how it will work is like exactly how it was like shown in the example code. Is like there are two makers, maker 16102, and there is another maker coming up. Let it come, let it come. And there is a taker is one, maker 6102 and maker 16102. These are the two makers, and taker and maker are gonna do a swap. So bunch of stuffs happen, some swapping connections. So watchtowers are automatically spawned by each maker, so it doesn't need external watchtowers are inbuilt. And then it's waiting for some communication to happen. Let's see. I hope it runs and doesn't break on my face. Yes. So taker and maker said hellos to each other. They gave offer, and boom. So like it will go do some boom boom stuffs, and will go it slowly. So taker and maker does some offers and say hello to each other. They got offer, and then they initiates the swap. And here's the taker is broadcasting the funding transaction. He in between they does the initial contract signing. Taker is happy, and it broadcasts the funding transaction. And taker like waits for the funding transaction to confirm, like the default one confirmation for now in demo. And taker saws it, sees it in mempool. And then it goes to 6102. So it goes to 6102 and sends the proof of funding and says like, hey 6102, I have like done the funding for you. 6102 checks the funding, and proof of funding is valid, and checks all the amount and stuffs. And then it says like, okay, give me the data for the next hop that I need to do as a maker. And so then taker goes to the next maker, sends some hello, they always do a hi hello at the start. So does the hi hello and gets some data and goes back to 6102 and sends 6102 the data. But here 6102 does something nasty. 6102 was supposed to go and broadcast a funding transaction after getting the 16102 data, his next swap transaction, but does not. He like drops off and taker is waiting. Taker is waiting, taker is waiting, taker waits for 10 seconds and now taker is angry. Now taker sees like he was supposed to wait for a funding transaction and maker goes away. So now his funding transaction is already broadcasted with 6102 and 16102 is good. 16102 hasn't done anything. Fundings are supposed to come to 16102 and then will 16102 will make the funding with the taker. But that did not happen. So we basically run a deviation case. Anybody can go if you have a Rust compiler, if you have a Rust thing running, we have the functional test and we cover all these cases and there is a standard swap where nothing goes wrong. So by running the standard swap, you will see like what happens when it follows the good path. So here we are following a bad path and this is what happens. The first funding hop is 144 time locked. 144 block time lock. Taker has no other way. So this has happened. What happened here is this. Take Alice talked with Bob. Bob was supposed to create this funding transaction. Alice went first and created the funding transaction. He already have a signed contract transaction. Bob didn't broadcast his part. Bob didn't do his deed. Bob disappeared. Now Alice has to get back to her fund via time lock. So this is what it looks like. Alice now broadcasts the outgoing contract transaction and now it waits for time lock. And here's the block at 135, 154, it reaches the time lock maturity hits. Now he spends the time lock contract transaction and gets it back to his wallet. Alice is happy. 6102 is like, meh, nothing happened to me, so I'm good. He is shutting down, and that's the end of the test, right? So if if we go ahead, I'll just complete something else. Is like if you go to about case of all the cases, so the doc above the case documents what the case describes. Our case infrastructure is like very simplified and I'm quite happy with how it looks like. It's very simple Rust code and you can define your own network infrastructure, like network at the start with just by creating this map. So and you can add like misbehavior to various nodes. So you can like simulate various protocol edge case situation and the call over here, the development support, the actual like the hard part of development is like find cases that I have missed over here. So these are all the cases that we could like I could figure out, and there could be other cases that I have missed, but all the cases looks very same, and it's about creating a network configuration at the start and applying like misbehaviors to various makers, and then various makers does various nasty things, and then see the other guys are doing whatever they're supposed to do or not. So this one consists of 3 makers and 1 taker. Everyone has 1 taker by default. The standard one, if you look at its network, 2 makers and 1 taker, and everybody behaves normally. So just by changing this map, you can like keep everything else same and just hit run and something will simulate. Some test will break, some assert will fail, so you will have a test failure, but at least you will see the log, and that's quite interesting to watch. Okay, if we go ahead.
So if you go back to the diagram, yes. So I think on Bob's, his behavior is not good for the ecosystem. If Alice determined that Bob is a bad actor, uh, how to use this information for rest of us, for rest of maybe for Dave and for some other person.
Centralized DNS server kind of things, or P2P gossip network between various Alices. Those are the only 2 answers for that. And that's not implemented. So right now, if Bob does something bad and goes away, and Alice, yeah, right now Alice doesn't tell anybody, so nobody knows. But yeah, like the way to solve that would be to create some kind of like DNS book or address book or something like that. We have that as our beta roadmap. That's a big part of like, it's not a protocol level engineering, it's kind of like basic computer science engineering. And the actual nice way of doing it would be like a P2P gossip network between various Alices. Then you don't have centralization on the DNS. So there are two questions like that. How does Alice know who are the other Bobs out there and how to connect with them? And how does other Alices know who are the bad Bobs out there? And they require some peer-to-peer engineering to solve. But it's not an unsolvable problem. It can be solved. Okay, Bitalu had raised his hands. So Bitalu, you want to go ahead?
It was by mistake. Yeah.
Okay, no worries. Cool. So like I will not like put any other information on this part of the call. I guess like the demo was fun, it ran, and if you just run other ones, you'll see outputs like this. And you can read through and see what is happening. I tried to make as much a sense as possible and sanitize the log, but it can be sanitized a lot. So another thing I just want to broadcast out there at the end is like contributing is like we have so currently our project is going on in this repository, and we have this roadmap that we are trying to follow. These are the remaining tasks until beta release. These are the tasks that are already done. So major part of the protocol and Alice and abort cases and simulation framework and Clippy warnings and basic testings are done. So we are like, it's quite mature. It's much mature than where it was last year. And then there are some open issues and some are good first issues. So feel free to take up any one of them. We don't have any discussions, but it's a kind of project, especially what fellow Jitsu was asking, is a kind of project where this kind of discussion board is actually very helpful. So feel free to create an open a discussion, or we do our development discussion in a Bitshala kind of semi-private channel, not public. So if you drop into our Bitshala Discord or ping me or any of the admin that you want a visibility into the Coinswap live discussion, dev discussion happening, a few people are already working on it. Some people are solving issues, and we have like kind of like I think commit history, kind of like community contribution going on lately. Insights would show is yeah, Chris Belcher. Then yeah, few people, Shoria and Rajat, started contributing and made some nice contribution that like got through our many of the major milestones. There are still few good first issues, easy hanging fruit to do. Then there are like bunch of other hard things to do. So if you know Rust devs out there, Bitcoin privacy focused, have some spare time in their weekends, wanna do something privacy and fun and impactful, send them. Yeah, you know the link. So I'll just still post it in the chat over here for easier purpose. And I will also post the link to our Discord invite that you can send to other people or join yourself. Just drop me a hi that you got it from the Bitdev and I will add you to the channel. Okay, cool. So any last round of question or we will drop off. Awesome. So thank you everybody for joining in and thank you for the amazing questions. Recording of this session will be uploaded in our YouTube channel, announced in all the usual places. Look for our tweet, look in the Discord channels, and we will see for the next session. Hopefully by 2 weeks. If something major happens, we will announce it accordingly. So take care and bye bye.